All right, so we have a gas with initial temperature of 900 degrees Celsius, which undergoes the process shown in the figure below. We see that the pressure here remains constant while the volume decreases by a factor of 3. So if the volume goes from 300 to 100, whatever the temperature is, it will drop by a factor of 1/3 of the original temperature. So given that the original temperature is 900 degrees Celsius, to figure out this in Kelvin is going to be 1173. Kelvin would be the initial temperature. A third of 1173 will be 391, and that is degrees Kelvin, and that is your final temperature. All right, so looking at this, we can see here that our volume decreases and our temperature goes down. So initially, particles again are moving very quick to very slow. Pressure versus temperature. We see that since the pressure stays the same, the temperature will drop by roughly a third. The volume and the temperature drop, so this will be a diagonal line going down with the initial state and the final state. Since the volume decreases, the environment pushes more. So that means when the environment pushes more on the box and the box gets pushed to the left, you have positive work going into your system, and the temperature drops by a decent amount. So you're going to have a negative change in internal energy, which means it's going to be undergoing a large cooling process. So you should expect a large negative Q as your answer for the heating process. So in order to figure out the change in internal energy, we are going to need to know the number of moles. The pressure is 3 times 10 to the 5th pascals, which is that in atmospheres, 3 atmospheres. Looking at the conversion from last page, or last problem, this is going to be 0.0003 meters cubed divided by 831 joules over moles times Kelvin times the temperature initially, 1173, which will give us 0.0092 moles. Okay, to figure out the change in internal energy, we are going to have 3/2 times nR, and the final temperature minus the initial temperature, which would be 3/2 times 0.0092 moles times 8.31 joules over moles Kelvin, multiplied finally by the change in temperature, so 391 Kelvin minus 1173. And when you calculate all this out, the change in internal energy is going to be negative 90 joules. That being said, we also have to figure out the work. So there's a couple ways we can do that. Since pressure is constant, we can use the equation, or we could also look at the area underneath the curve. So the work here is going to be 3 times 10 to the 5th pascals minus the difference in 0.001 meters cubed minus 0.003. I'm missing a 0 there. An extra 0. An extra 0. So ultimately, since it gets smaller and we look at the equation, we're going to have a positive value for our work. So this will be positive 60 joules of work. Looking at the heating process Q, in this case, it's going to be a cooling process because Q is going to be negative. So we go from positive 60 to equaling the change in internal energy, which is negative 90 joules. And then Q will ultimately be equal to